back to the resistor combination lab, this time part 3. We're going back to that mixed set of 5 resistors we examined in the comparison lab. There's a brown, green, brown, gold, a brown, green, black, red, 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 black, red, orange, orange, black, red, and brown, black, black, gold. Take a second, use your code to figure out the nominal resistance for each. Next, use a multimeter to measure the resistance for each one. These are all in ohms. Now, we're going to hook them in series. Let's attach a brown, black, black to an orange, orange, black. Again, we'll connect them with one alligator clip, leaving the other loose. And here we go. We have the equivalent resistance of the two in series. Now, let's connect several pairs together in parallel. We'll start with a brown, black, black, and a brown, green, black. And there you go, 6.2 ohms. Next, let's attach the brown, black, black to a brown, green, brown. And we have 9.7 ohms. Finally, let's attach a red, red, black to an orange, orange, black. $13.3 ohms. I think you probably will go straight to the series rule. The parallel rule is a little harder to figure out. What I'd like you to do is start with a 10 ohm resistor by itself. Next, add another path for current to flow, another 10 ohm resistor. Side by side, there's now 2 paths, and I think you know the equivalent resistance of the two 10 ohms would be 5 ohms. Now, instead of a 10 ohm, start with a 10 and put a 15 ohm in parallel. This time it's more than 5 ohms, but it's still quite a bit less than 10 ohms. You've got a measured value for the 10 and 15 in parallel. Next, put a 10 and a 150 in parallel. Now, it's pretty close to 10 ohms. That 150 ohm path didn't help much in letting charge flow through. Imagine what would happen if you put a 15 million ohm resistor in parallel with a 10 ohm resistor. It might just say 10 ohms. It wouldn't have much effect at all. So, what we're seeing is the bigger the added resistor, the less it changes the equivalent resistance. What kind of function gets smaller as X gets bigger? Hopefully, you are thinking of an inverse function. If you can't figure it out, take a quick look at the notes page. That's all for now.